So this is the review video for Unit 1, Equations and Inequalities. Remember that our exam 1 is on Thursday, so you have about 2 more days to prepare for the exam. Please use your lesson videos and the notes to prepare for the exam. Pay close attention to this video because it works out a lot of examples for you guys to help you prepare for your exam. Please do not come to the exam unprepared. Use this next 2 days to study and be ready for our exam. We'll get started with working on the review that I gave you guys. Either you got it last week on Thursday or you got it today on Monday. This review covers the equations and inequalities. So the first part we're going to take a look at is solving multi-step equations. So I picked some of the problems there in your review, and I worked out the problems, and then I also checked it so you know exactly how to do solving multi-step equations and how to check your answers. So the first problem we're taking a look at is 5z plus 16 is equal to 51. So remember that when we're solving equations, we need to isolate the variable that we are looking for. In this case, that is z. So to isolate z, we're trying to move the plus 16. We need to do the opposite of adding 16, which in this case would be subtracting 16, both sides of the equation. Now you end up with 5z is equal to 35. 51 minus 16 is 35. You want z by itself, so you need to undo the multiplication of 5, which means you're going to divide both sides of the equation by 5, and you'll end up with z is equal to 7. Most of you stop right here when you get z is equal to something. Well, my suggestion is, especially for this test, is that after you get your answer or your solution is to check your work. Remember that I do give you guys points for checking your work. So to check your work, the thing you're going to do is substitute 7 for z. So now you're going to have 5 times 7 plus 16 is equal to 51. 5 times 7 ends up being 35. 35 plus 16 gives you 51. The left-hand side of the equation is equal to the right-hand side. 51 is equal to 51. So that means we did everything correctly and we ended up with z is equal to 7. Now let's move on to problem 4. Problem 4 right here, let's scroll this up a little bit so you guys can see it. Problem 4 right here shows you that we have quantity 4b plus 8 all over negative 2 is equal to 10. So to solve this, we still have to do the same thing. We need to isolate that b, the variable we are looking for, by itself. So to do that, we multiply both sides by negative 2. That would get rid of the negative 2 in the denominator. So from there, that cancels out. We're left with just 4b plus 8 is equal to 10 times negative 2, which is negative 20. We want b by itself, so we're going to add 8 to both, subtract 8 from both sides so that we can cancel that plus 8 right there. So now we're left with 4b is equal to negative 20 minus 8 gives you negative 28. To get b by itself, we divide both sides by 4. You're going to end up with b is equal to negative 7. Now to check your work, same thing. You're going to substitute b is equal to negative 7 into your original equation. So you substitute it in, you're going to end up with 4 times negative 7, that gives you negative 28. Negative 28 plus 8, that gives you negative 20. Negative 20 divided by negative 2, negative divided by a negative gives you a positive. In this case, it's a positive 10. That's equal the right-hand side with a positive 10 also. So you know that for problem 4, b is equal to negative 7. Notice that I am working out different problems in the review. I'm specifically working problems that are not the same so that you can see different ways of solving equations. That being said, let's move to problem 7 of solving multi-step equations. Let me move this up. So here is problem 7. Problem 7, we have 7 over 8p minus 4 is equal to 10. So to solve for p, we need to isolate p by itself. First thing we're going to do is, since it's a minus 4, we're going to add 4 to both sides. Now we end up with 7p is equal to 10 plus 4 gives you 14. From here, we need to get rid of 7 over 8. So to get rid of 7 over 8, I'm multiplying both sides by 8 over 7. You can see that the 8s would cancel out, and then the 7s would cancel out. Then I'm left with p. So if I multiply this side by 8 over 7, I'm going to have to do the same thing on the right-hand side. So now from here, we're going to have 14 over 7, which would give you a 2. 14 over 7, 2 times 8 would give you a 16. So p is equal to 16. Now just like how we checked our work with problems 1 and 4, we're going to substitute 16 for p. So we have 7 over 8 times 16 minus 4 is equal to 10. 16 over 8, that would cancel out to 2 over 1. You're going to have 2 over 1 times 7, which would give you 14. So 7 over 8 times 16 is 14. 14 minus 4 gives you 10. 10 is equal to 10. That means that p equals 16 is the correct answer for problem 7. Now let's move on to other multi-step equation problems. So right here we have another example of solving multi-step equations. This is problem 9 in your review. We have negative 4 is equal to quantity 7x minus negative 1 all over negative 8. So from here, we need to get rid of the denominator first, the divided by negative 8. As you can see right here, I multiplied both sides by negative 8. But also, notice that right here, I changed the minus a negative 1 to plus 1. Minus a negative 1, that just means plus 1. So now right here, negative 8s will cancel out on the right-hand side. Negative 8 times negative 4 will give you a positive 32. So now our equation looks like this. 32 equal to 7x plus 1. We want to isolate 7x by itself, so we need to get rid of the plus 1. Minus 1 here, minus 1 there. We're going to end up with 31 over 7, or 31 is equal to 7x. To get x by itself, we divide both sides by 7. Now we end up with x is equal to 31 over 7. Now to check our work, we just plug that in up here. Notice that the 7 in the numerator and the 7 in the denominator would cancel out. You'll be left with 31 plus 1 minus a negative. It'll become a plus 1. That's 32. 32 divided by negative 8 is negative 4. So the left-hand side is equal to the right-hand side. So we know that for problem 9 in multi-step equations, x is equal to 31 over 7. Now let's move on to the other part of the worksheet, which is, or the review, which is solving equations with variables on both sides. Let me move this up so you guys can see it. There we go. So right here, rather than just having one of your variables already on one side of the equation, now you have your variables on both sides of the equation. So your goal is to move all the variables on one side of the equation and then the numbers or anything else on the other side. There's really no preference if you move it to the left-hand side of the equation or if you move your variables to the right-hand side. It's just a matter of how you want to set it up. So for problem 1, we have negative 3 times quantity x plus 5 is equal to 3 times quantity x minus 1. So the first thing we're going to do is we're going to distribute that negative 3. So we're going to end up with negative 3 times x gives you negative 3x. Negative 3 times positive 5 gives you negative 15. We'll do the same on the right side. We're going to end up with 3 times x gives you 3x. 3 times negative 1 gives you negative 3. Now I want to isolate the x, or I want to move all the x's to the left-hand side of the equation. So I'm going to move this positive 3x
to the other side. To move it, since it's a positive 3x, I'm going to have to subtract 3x from both sides of the equation. So now we're going to have, this would cancel out. I'll be left with just negative 3 on the right hand side. Negative 3x minus 3x gives you negative 6x minus 15. I just brought that negative 15 down, is equal to negative 3. Now I want negative 6x by itself on the left hand side, so I need to get rid of the negative or the minus 15. So now I'm going to add 15 to both sides. We're going to end up with negative 6x is equal to 12. Negative 3 plus 15 is 12. Then you divide both sides by negative 6 because you want x by itself. So you're going to end up with x is equal to 12 divided by negative 6 is a negative 2. Positive divided by a negative gives you a negative. So x is equal to negative 2. Now, the same thing that we did with solving multi-step equations, to check your work, you take x is equal to negative 2 and substitute it inside your original equation, which is this one right here. You're going to end up with negative 3 times quantity negative 2 plus 5 is equal to 3 times quantity negative 2 minus 1. Negative 2 plus 5 gives you a positive 3. Negative 3 times positive 3 gives you a negative 9. Now let's check the right hand side. Negative 2 minus 1 gives you a negative 3. Positive 3 times a negative 1 gives you a negative 9. The left hand side and the right hand side both equal negative 9. So we know that x is equal to negative 2 is the solution for this equation. Let's move along to the other slides to see some more practice or some more solutions. So now let's take a look at problem 5. Problem 5, we have 3 times quantity a plus 1 minus 5 is equal to 3a minus 2. So starting out with our original right there, we distribute the 3. 3 times a gives you 3a. 3 times 1 gives you a plus 3. So we have 3a plus 3 minus 5 is equal to 3a minus 2. So from there, we can combine plus 3 and minus 5. That will give us a negative 2. Now if we continue solving this, I can move this positive 3a to the other side. So I'm going to subtract both sides with 3a. So minus 3a, minus 3a. But look what happens right here. This cancels out, and I'm left with just 0a. So the a's are gone, and I'm just left with negative 2 is equal to negative 2. Because negative 2 is equal to negative 2, and that is a true statement, that means that the solution for this equation is all real numbers. That means that whatever a is, it could be any number, any real number, and once you plug it in, it'll still end up the left-hand side equaling the right-hand side. So the answer for number 5, because of this true statement right here, is all real numbers. Now let's move on to problem 11. We're still at solving equations with variables on both sides. We're looking at problem 11 right there. So let's move this up so you can see it. So with problem 11, we have 2 over 5 w minus w is equal to negative 1/5 times the quantity 3w plus 2. So from there, the first thing I did was to combine these w's together. We have 2 over 5 w minus 1w. So you need to find a common denominator. In this case, it would be 5. This would change to a negative 5 over 5w. So now from there, you have 2w minus 5w all over 5. That's going to give you a negative 3 over 5w is equal to, if you distribute that negative 1 over 5, negative 1 over 5 times 3w, that'll give you a negative 3 over 5w. Negative 1 over 5 times 2 will give you a negative 2 over 5. So this is what we have now. We have negative 3 over 5w is equal to negative 3 over 5w minus 2 over 5. If I want to move this negative 3 over 5w to the left-hand side, I'm going to have to add it to both sides, as you can see right there. After adding it, you're going to see that negative 3 over 5w plus 3 over 5w, that cancels out. I'm left with a 0. 0 is equal to negative 2 over 5. That right there is a false statement. Because it's a false statement, you know that in this equation, there's actually no solution. So you will not be able to find any value, any number that you can plug into W and actually have a solution. So this is the flip of the previous problem that we worked on. The previous problem had all real numbers as the solution. This one has no solution at all. Alright, let's continue with problem 15. We're still at solving equations with variables on both sides. Remember that a big part of this, when you have variables on both sides, you need to be able to move the variable to one side of the equation. It could be either on the left-hand side or on the right-hand side. So right here we have negative 5 times 2r plus 3 equal to 3 times quantity 11 minus 4r close quantity minus 58. First thing we did was distribute. We end up with negative 10r minus 15. Negative times a positive gives us a negative 15. Equal to 3 times 11, which is 33, minus 12r, that is 3 times negative 4r gives you a minus 12r, minus 58. On this right-hand side, we can combine 33 minus 58. That will give us a negative 25. So now the right-hand side is negative 12r minus 25. That's equal to negative 10r minus 15. Now if I move the negative 12r to the left-hand side, since I want all my variables on one side of the equation, I'm going to add 12r to both sides. This would end up canceling out. It'll just be negative 25 brought down there. Now we have negative 10r plus 12r. That'll give you a 2r. And then you bring down the minus 15. We want 2r by itself on this side of the equation. So we're going to add 15 to both sides. Once we've added 15, we're going to end up with 2r is equal to negative 10. We want r by itself, so we're going to divide both sides by r. There's the over 2 over 2. You end up with r is equal to negative 5. Now from here, r is equal to negative 5. We can plug it in or substitute it in the original equation. And as you can see, once we substitute it in, once we work it out, you're going to end up with 35 is equal to 35. So that means r equal negative 5 is a solution to this equation right here. Now we're going to move along to solving inequalities. We're going to start out with a basic one. We're going to start out with solving inequalities by using addition or subtraction. So right here, we're going to take a look at problem 2. We are already on the third page of the review. We have 9k minus 12 is greater than 80 plus 8k. So if we want to solve this, just like equations, we have to isolate the variable on one side of the inequality. So in this case, I moved the minus 12 from the left-hand side to the right-hand side. So I add 12 to both sides. We end up with 9k is greater than 92 plus 8k. We want all the k's on the left-hand side, so I'm going to subtract 8k from both sides to get rid of that plus 8k. Now we end up with k is greater than 92. Now on your test, you may be asked to graph this inequality right here. To graph this inequality, notice that you have k is greater than 92. So you're going to draw your number line. You're going to mark where 92 is. I mark the other numbers right here so that I just know which way is less than 92 and which way is greater than 92. So in this case, because it's just a greater than symbol, there's no equal to, it's just greater than, you use a hollow circle or just a circle to plot it. So there's the 92. Because it's greater than 92, we're going to go to the right of 92. That's why the arrow and the line is on that side. So this right here, this graph right here in the number line is the graph of k greater than 92. Now to check your work, the same thing as what we did with equalities. Now with inequalities, you're going to have to pick a number that is greater than 92. So in this case, I just picked 93. If you substitute that number that is greater than 92 in your original inequality, right there, when you do your calculations, your inequality needs to be true. So right here we ended up with 825 is greater than 824. Because it is true, we know that k is greater than 92 is our solution to this inequality. I know there's a lot of steps there, but please, 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 take your time to study this. You already saw this in your notes. Lessons 1 through 6 covers all the inequalities that you need to know. Alright, let's continue practicing solving inequalities by addition and subtraction. So right here, problem 6, we have 3 over 2q minus 25 over 5 is greater than or equal to 2q over 4. So the first thing that I say right here is simplify and rewrite. I say simplify because when you can reduce your fractions, it would be to your best interest to reduce the fractions. The 3 over 2q, we can't do anything, so we just leave it as 3 over 2q. However, the minus 25 over 5, 25 over 5, that's 25 divided by 5. That'll give you a 5. So rather than write minus 25 over 5, we're writing just minus 5. And then lastly, we have 2 over 4 right here. 2 over 4 reduces to 1/2. So rather than have 2q over 4, we can just write it as 1 over 2q. So now from this point right here, we need to isolate our q. So the first thing I did was to add 5 to both sides to get rid of that negative 5 on the left hand side. Now we have 3 over 2q is greater than or equal to 1/2 q plus 5. We need to move that 1/2 q to the left hand side, so we subtract 1/2 q on both sides. 3 over 2q minus 1/2 q, that gives you 1q, or you can just write q, and then that cancels out, you're just left with 5. So our solution is q is greater than or equal to 5. So now right here, if we plot that, we're graphing it, you can see that because you have a greater than or equal to, there's the equal to part, we are not using a hollow circle. We're actually using a shaded dot. So that marks the 5, because that means it could be equal to 5. That's why it's shaded. Now from here, which way is greater than 5? 6 is greater than 5, so our arrow, our solution would go to the right of that shaded dot. To check your work, you can pick any values that are greater than 5 and see if you end up with a true statement when you substitute it in your inequality. So the solution for problem 6 is q is greater than or equal to 5. Now let's move on to another example. Let's look at problem 10. So problem 10 is right here. Problem 10, we have 1 over b plus 4 is less than or equal to 10 plus 1 over b, provided that b is not equal to 0. So when we solve this out, I want all the variables on one side of the equation, so I'm going to move the plus 1 over b to the other side. Subtract 1 over b from both sides. This cancels out, but this also cancels out. So we end up with 4 is less than or equal to 10. Because that statement right there is a true statement all the time, we know that our solution would be all real numbers except for b is equal to 0. B cannot be equal to 0 because if b was 0, this part right here is not going to divide correctly. You cannot divide any number by a 0. That would be undefined. So the graph of this solution would be, as you can see, at 0, we put an open circle. That means that 0 is not part of the solution. And then all real numbers, so that means you'll keep going to the right to positive infinity, and then you'll keep going to the left to negative infinity. So pay attention to what kind of dots you're going to use. If you're only dealing with greater than or less than, you're going to use a hollow dot. If you're dealing with greater than or equal to or less than or equal to, you're going to use a shaded dot. So now let's continue to the other exercises or the other parts of the review. Now we're solving inequalities using multiplication and or division. So problem 1 is a very simple one. We have 4s is less than 24. We want s isolated by itself. So we're going to divide both sides by 4. S is going to end up less than 6. This right here is the important part when you're dealing with multiplying or dividing with inequalities. The inequality symbol, that one right there, would reverse or flip whenever you multiply or divide both sides. That's the key to it. Both sides of the inequality by a negative number. In this case, we divided by 4 on both sides, but 4 is not a negative number, so the sign stayed the same. So the graph of this solution right here, you can see it's just less than, so it's an open circle, marking it at 6, and then because it's less than, we're going to go to the left of 6, right there, and there's our graph for this problem. Now let's look at problem 4, where you will see the sign flipping. So here's problem 4. Notice that in problem 4, we have 7 over 3 is less than negative 9 over 1n. So I want to isolate n by itself, so I need to get rid of the negative 1 over 9. So I multiply both sides by negative 9. This would cancel out. You're going to be left with n. There's your n right there. Negative 9 times 7 over 3. Negative 9 divided by 3 will give you negative 3. Negative 3 times 7 will give you negative 21. Notice that right here, the sign is a less than, but because I multiplied both sides by a negative number, the sign flipped and turned into a greater than symbol. So now if I'm reading this, it's negative 21 is greater than n. Or if I read it from left to right, it's n is less than negative 21. So if I want to rewrite this, where the variable is on the left side, I just have to make sure that when I read this, it matches this right here. So this is n less than negative 21. I rewrote it. It's n less than negative 21. So these two right here are actually the same inequality. So now to graph it, you can see that it's a hollow circle again because it's only a less than symbol. And then we go to the left of negative 21 because we are looking at a less than negative 21. So this right here is the graph of this solution. Let's look at problem 11 right here. Let me scroll this up. So problem 11 right here, we have 2a all over 7 is greater than or equal to negative 6. If I rewrite this, you can rewrite it as 2 over 7 times a is greater than or equal to negative 6. So if we want to get rid of the 2 over 7, since we're multiplying 2 over 7 by a, we can divide both sides by 2 over 7. This would cancel out. You'll be left with a. The sign didn't flip because you didn't divide or multiply by a negative number on both sides, so the sign stays the same. But then this right here, this is where your keep, change, flip would be occurring. We're going to keep the negative 6. We're going to change the divide to a multiply. And then we're going to flip 2 over 7 to 7 over 2. Now you're going to end up with negative 6 times 7 over 2. Negative 6 over 2, that cancels out to a 3. You end up with negative 3 times 7, which would give you negative 21. So now A is greater than or equal to negative 21. Because it's greater than or equal to, notice that we're using a shaded or a filled in dot. You can see that it's all filled in right there. It's not a hollowed out dot. Now because we're looking at greater than or equal to negative 21, the values that are greater than negative 21 would be to the right, because negative 20, 0, 1, 2, 3, 4, 5, they're all to the right of negative 21. So those are the numbers that are greater than or equal to negative 21. So this right here is the solution, or the graph of this solution right here to our inequality. Right? Just make sure that you remember this part right here. This part right here. Whenever you're dealing with inequalities, it's very important that you remember that whenever you multiply or divide by a negative number on both sides of the inequality, then your sign would flip. That's very important that you remember that. A lot of students make that mistake on the tests. Now that you've practiced solving inequalities using addition, subtraction, and then using multiplication and division, now we're going to combine all those and look at solving multi-step inequalities. So the first one we're going to take a look at in your review is problem 3. We are at solving multi-step inequalities. So we have q over 7 plus 1 is greater than negative 5. So from here, we want to isolate q over 7 by itself. So we need to get rid of the plus 1. Minus 1 on both sides, you're going to end up with q over 7 is greater than negative 5 minus 1 gives you negative 6. We want q by itself, so we're going to multiply. We're dividing by 7, so we're going to multiply both sides by 7. Because we're multiplying by a positive number, the sign will stay the same. You're going to end up with q is greater than negative 6 times 7, which is negative 42. To plot it, here's our graph. Because it's a greater than symbol, there's no equal. It's just greater than. We're going to use a hollowed circle. Because we're looking at greater than negative 42, we're going to draw the line or the arrowhead to the right of that hollowed out circle. So this right here is the graph of q is greater than negative 42. Now let's move on to problem 5. Let's scroll this up so you can see it. As you can see right here with problem 5, we have 3x over 7 minus 2 is less than negative 3. We want to isolate 3x over 7 by itself on the left hand side. So we're going to add 2 to both sides. Notice that this is minus 2. So we're adding 2 to both sides. That cancels out. This one is going to be negative 3 plus 2 will give you a negative 9. We want to get rid of 3 over 7. So I'm going to multiply both sides by the reciprocal of 3 over 7, which is 7 over 3. This is just more of a shortcut of that keep, change, flip. I'm just not showing you step by step what's happening. Notice that 7 over 7 cancels out. 3 over 3 cancels out. So now we're left with x on the left hand side. Now on the right hand side, you just have negative 1 times 7 over 3. That'll just give you negative 7 over 3. So now here's our solution. To plot it, we mark where negative 7 over 3 is. We know that negative 7 over 3 will give you a 2 point something. So to the left of it would be negative 3. To the right of it would be 0. Because we're looking at less than, no equal to it, we're using a hollow circle. And then because we're looking at less than, that means we're going to draw the arrowhead to the left of that hollowed circle right there. Let's look at one more right here, problem 6. Let me move this up. Here is problem 6 right here. You can see with problem 6, we have 4x minus 2 all over 5 is greater than or equal to negative 4. So we want to isolate 4x or x by itself. So the first thing we have to do is to get rid of the last thing that's happening, which is divided by 5. So to undo that, we multiply both sides by 5. We end up canceling this 5's right here. You're going to end up with 4x minus 2 greater than or equal to negative 4 times 5 is negative 20. We want 4x by itself, so we need to get rid of the minus 2. Plus 2 on both sides, you're going to end up with 4x is greater than or equal to negative 18. We want x by itself, so we're going to divide both sides by 4. You're going to end up with x is greater than or equal to negative 18 over 4. When you reduce that, you get negative 9 over 2. So we plot this inequality right here. Because you have a greater than or equal to, you have that equal to part, we're going to use a shaded dot. So there's our shaded dot right there. We shaded negative 9 over 2. That's 4.5. So it'll be between negative 5 and negative 4. We know that we're looking at x greater than or equal to negative negative 9 over 2. So we know we're going to shade to the right of that shaded dot right there. So this right here is the graph of x is greater than or equal to negative 9 over 2. Now let's move on to the other inequalities. Alright, let's take a look at two more multi-step inequalities. This one right here, we have problem 11, which is m plus 17 less than or equal to negative quantity 4m minus 13. So the first thing I did here was I distributed that negative right there. Negative times 4m gives you negative 4m. Negative times negative 13 gives you a plus 13. Now we want to isolate m on one side. So we want to move all the m's on one side of the inequality. I chose to isolate this m right here, so I added 17 on both sides. Now from there, you're going to end up with m is greater or less than or equal to negative 4m minus 4. I have to put all the m's on one side of the inequality. So I'm adding 4m to both sides. This would cancel out. You'll be left with just negative 4. This would become m plus 4m will give you 5m. So now we have 5m less than or equal to negative 4. We want m by itself, so we're going to divide both sides by 5. Notice that we're dividing by a positive 5 on both sides, so the sign would stay the same. Now we have m is less than or equal to negative 4 over 5. So to plot that, here's our plot for it. Negative 4 over 5, that would be between negative 1 and 0. Because it's a less than or equal to, there's that equal to, we're using a shaded dot. And then because we're looking at less than or equal to, we will draw the arrowhead pointing to the left of that shaded dot. Lastly, we'll take a look at problem 12. So problem 12, just still another multi-step equation. This time we have negative 5x minus quantity 2x plus 3 is greater than or equal to 1. Not negative 1, just 1. So from there, we distribute the negative. We're going to end up with negative 5x minus 2x minus 3 is greater than or equal to 1. Well, the negative 5x and the negative 2x we can combine. That will give you a negative 7x minus 3 is greater than or equal to 1. We want negative 7x by itself, so we add 3 to both sides. Now we're ending up with negative 7x is greater than or equal to positive 4. We want x by itself, so we're going to divide both sides by negative 7. There's negative 7 divided by negative 7. There's another divided by negative 7. Because we divided by a negative number, notice that this sign right here actually flipped. So it reversed. It flipped. So now we have x is less than or equal to negative 4 over 7. So now we plot it. Here's our negative 4 over 7. We're using a solid or a filled-in dot because of the equal to part. Now because we're looking at x is less than negative 7, there's a typo right here. The solution to this one would actually have to be going the other way, because this is less than or equal to negative 4 over 7. So the solution should be going this way. So take note that the correct answer is the one in blue and not the one in red. I plotted it wrong. I plotted greater than negative 4 over 7 rather than less than or equal to 4 over 7. So this should be the correct answer right there. Alright, we're on the last part of or the last two slides. Now we're looking at solving compound inequalities. Note that on your study guide or on your review, each page has a study guide part where it actually goes through some examples and it works it out for you step by step. Please use that. Alright, especially for the compound inequalities one, it has 4 examples there that you can use in order to make sure that you understand how to solve compound inequalities. So right here, we're dealing with problem 4. Problem 4 deals with 2x plus 4 is less than or equal to 6, or x is greater than or equal to 2x minus 4. So from there, we need to solve each inequality. If we work it out, you're going to end up with this one right here is x is less than or equal to 1. And then on this side right here, you're going to end up with x is greater than or equal to 4. Because we're dealing with OR, we're looking for the union of each solution. So I'm going to scroll this up so you can see it. You can see right here that the union of this two right here would just be the entire thing. So we're going to say x is less than or equal to 1 or x is greater than or equal to 4. This entire thing right here is the solution. That's when you're dealing with OR. Now let's take a look at AND. With AND, we deal with the intersection. So OR is the union of the entire thing, and we deal with intersection or the overlap of the solution that you are looking at. If there is no overlap in your compound inequality, if you're dealing with AND, that means you have no solution. So right here we have your two inequalities. There's your compound inequalities. We solve it out. You end up with G is less than 4. And then on this other side right here, we end up with G is greater than negative 3. Now if we scroll this up a little bit so you can look at the graph a little bit closer, you can see that we plot G is less than 4. So there's 4 right there. We use a hollow circle because it's just less than, and then less than 4, so the arrowhead points to the left. We have G is greater than negative 3. There's negative 3 right there. We're using a hollow point again because it's just greater than, and then you can see that the arrowhead points to the right. The overlap happens right here. From here to here. That's where the overlap happens. So that means your solution would be those two right there. You're going to have G greater than negative 3 and G has to be less than 4. That's this area right here. That's how you represent that area when you're writing it in notation. So you have a lot of examples already here for your test on Thursday. Please, please, please use the review, use your lesson notes, use the lesson videos in order to make sure you are prepared for your exam 3. It is very important that you do well on exam 3, being that we're almost done with this first 9 weeks.